The review for the quantum physics quiz. Number 1. What were the basic elements that were first proposed by ancient philosophers? Way back in Greek times, when people were running around in togas, they thought that everything was made out of 4 elements: earth, air, fire, and water. For instance, ice would have less fire in it than liquid water. That's why ice is cold. And a bird would have more air in it than a lizard. That's why a bird could fly. That kind of a thing. Number 2. Each time that researchers found new information about atoms, they had to adjust their theories on how the universe works. Option B. Please remember that no matter how good a theory is, it can always be forced to be rewritten when we get new information. There is no such thing as settled science. Everything could potentially be wrong and need to be altered in some way. Number 3. You want to write the isotopic notation for lithium ions with 4 electrons and 2 neutrons. What number goes in the upper right-hand corner? Notice that numbers 4, 5, and 6 deal with the exact same lithium ions, so let's just write the whole notation right away. We have Li as the symbol for lithium. And according to the periodic table, we look at the chart and we try to find the Li, and it is over here on the left-hand side. It has the whole number 3 on it, so that's the number of protons. Proton number always goes in the bottom left. This story problem tells us the number of neutrons, 2. That goes in the lower right. We combine these two numbers together, add them together, and that's the total number of things in the nucleus. That goes in the upper left. In the upper right is the charge. It says here that we have 4 electrons. Those are negative things, 4 negative things, and we have 3 positive protons. So the balance of that is, let's see, we have more negatives than positives, so the net charge is going to be negative. And we have 1 more negative thing than positive things, so it's a -1 charge. There's our complete isotopic notation. So breaking this down into the 4 steps, the upper right-hand corner is -1. And I see that it should be option A. I should have a negative there, and I don't, so hopefully I will change that in your packets in the future. All these should be negatives. Maybe it's already been changed in your packet. Number 4, lower right corner, is the 2. Number 5 in the upper left corner is the 5, option E. Number 6, lower left corner, is the 3. Number 7, how many electrons does a normal boron atom have? Looking at the periodic table, boron is over here, and it has a whole number 5. So that's how many protons it has. And a normal neutral atom will have the exact same number of electrons. So number 7, the answer is E, 5. What atom has 12 electrons? If it's an atom, it's neutral. If it's neutral, that means it has the same number of electrons as protons. So we're looking for 12 protons. That'll be magnesium, Mg here. Option B. Number 9, what element has 4 protons? Periodic table, option, the box with the 4 in it is beryllium. And that is not given. Number 10. Usually, you can find the most common number of items in an element's nucleus by rounding the decimal number. That doesn't always work, but it works often enough that it's a close approximation. Number 11, what kind of particles are the components of protons and neutrons? They are made up of things called quarks. There are 3 quarks that make up a proton, and there are 3 quarks that make up neutrons. They have different combinations. Number 12, how many particles make up matter and forces in the Standard Model? There's a total of 17 according to that model. 17 different things that make up all matter and forces. There are things called leptons and quarks and bosons. Number 13. Particles in a particle accelerator move at almost the speed of light, which is 300 million meters per second. Option D. Number 14. After a collision, detectors in an accelerator detect matter and energy. They can see what kind of particles fly out of a collision, and they can also measure the energy of those particles, or the energy of photons of light, whether it be invisible light or visible light. Number 15. What can be accelerated in an atom smasher? You can only accelerate things that have charges of one sort or another, either positive or negative. So option C is going to be our answer. Option A is wrong because neutrons don't have a charge. They can't be accelerated. Option B is wrong because atoms are by definition neutral, so you cannot accelerate those. Photons don't have charges, and so they cannot be accelerated. Number 16. How big in diameter is the tube that contains particles to be smashed? Even though the outside appearance makes it look like they're 3 or 4 feet across, the actual tubes that are on the inside, where the particles are actually moving, are only 3 to 4 inches across. Option A. Number 17. What makes particles move in an atom smasher? The electric fields of microwaves. Number 18. What is the job of magnets in an accelerator? They guide the particles to stay in the tubes, to make the curves that most accelerators have as they go around and around. Number 19. How are trails made in a detector chamber? There are a couple different ways that they are done, but both of them have the similar quality of ionizing molecules. The energies and the particles that fly away from a collision knock off electrons from different kinds of materials. That's what we mean by ionizing. Sometimes this ionization makes little bubbles in a liquid, and so we see a trail of bubbles. Other times, this ionization causes droplets to form that look like little tiny clouds. But both ways are caused by ionizing molecules in the detector chamber. Number 20. In a detector, why are some trails curved and some are straight? The curved trails are made by charged particles. Straight ones are made by neutral. So the detector chambers have magnetic fields in them, and they cause some things to curve, and some things just go straight and are not affected by it. Number 21. In a detector, the particles that make up more tightly curved trails than others are less massive. If they are less massive, they are lighter and they are easier to turn, and so they make tightly curved trails. They make little tiny circles. A more massive particle is harder to turn, so it has a more gentle curve or a bigger circle in the detector chamber. Number 22, what is antimatter? Antimatter is just like regular matter, but it has opposite signs. Option B. So the antimatter particle of a proton is called an antiproton, and it looks like a proton. It has the same mass as a proton, but it has a negative charge. The antimatter particle of an electron is called a positron, It looks like an electron. It has the same mass as an electron, but it has a positive charge. Number 23. What happens when matter and antimatter meet? They turn into pure energy, which is called annihilation. So you start off with two particles, they meet, and they turn into photons of invisible light, very high energy gamma rays most likely. And that is the end of the review. I suggest you try to go through those and answer those questions without looking at the answer key.